In your previous math life, you've worked with radical form and you've worked with exponent form, but I'll bet you didn't know that they were connected to each other. For example, you know this is the square root of 4, which is 2, but this can be written with a fractional exponent. So square root of 4 is the same as 4 to the 1/2 power. If you see 4 to the 1/2 power, you know that's 2. You've probably never had a fractional exponent before, but you'll see the pattern very quickly. Square root of 9, technically you can write a 2 in there and you'll see why later, but since square roots are so common, we usually skip the 2. But this means the square root of 9, which means 3 got multiplied by itself twice to get the 9. If I wanted to write that with an exponent, that would be 9 to the 1/2 power. Square root of 49, you can put a 2 there if you want, but we normally skip that. Square root of 49 is the same as 49 to the 1/2 power. These are just two different ways to write the same thing. So now you can move on to what's called the cube root of 8. Now that there's a 3 there, you have to ask yourself, what multiplies by itself 3 times to equal 8? And your brain says, well, 2 times 2 times 2 is 8, so 2 is the cube root of 8. If you wanted to write that as a fractional or a rational exponent, that's 8 to the 1/3 power. Notice that whatever root we have here, that's the root in our fractional exponent. The cube root of 125 is 5 because 5 times 5 times 5 multiplied by itself 3 times gives us 125. Remember, if you skip writing that number, then everyone is supposed to assume that that's a square root. As soon as you write a number there, now they're focused on a different root. And you could go a little crazier, like the 5th root of 32, or 32 to the 1/5 power, the 4th root of 81, or 81 to the 1/4 power. So they're just two different ways to write a radical or to write a value. You can either choose a radical or an exponential form. It's just new to you that we could have fractions up there in the exponent. So let's take a closer look at the fractional exponent. Remember, the 3 in this case represents the root. So I could have written this as the 3rd root of 27, which means what number multiplies by itself 3 times in a row to equal 27, and that is 3. But what about that 1 up there? Let's take a look. Now let's call this 27 to the 4/3. We still have a radical, we have a rational exponent or a fractional exponent, but if I were to rewrite this in radical form, the 27 is still on the inside, the 3 is the root, so that goes there, and the 4 is going to be the exponent. And we're now going to work on how can we turn something like this into a final answer when the numerator is not a 1. And we'll use this one as an example. This one has a lot going on in this radical, but here's an exponent and here is a root. How did we get this answer of 16? So if I would rewrite this in exponent form, remember this is the root, so that's going to go as the denominator of the fraction. This is the exponent, and that goes as the numerator. If you ever forget about it, or forget which order it goes, think of the word root, the root, which implies down below, because think of where the roots of a tree are. The roots of a tree are down below. So the root of the radical goes down below in the fraction. And so now if you want to compute the answer, I would suggest this. The first thing you should do is think about the root. This is a 3rd root. So I can think about 8 to the 1/3, or what number multiplies by itself 3 times to give me 8. That's a 2. After I thought about the root, then I'll think about the exponent. I'll take my 2 and I'll raise it to the 4th power. 2 to the 4th power is 16, and that's how I got that. So what I did is I found the root of 8 first. The 3rd root of 8 is 2. Then I multiplied that 2 by itself 4 times to get my 16. I'm going to show you how you can do this on the calculator soon if you have coordinated thumbs. If you want to see if you're really understanding all that mess that we just did up top, try it with this one. I have a fourth root and a third exponent, and I should get an answer of 27, but can you figure out how you got that 27? Pause the video for a moment and see if you can do it. If you didn't pause the video to try, shame on you, you're naughty. You think you're going to learn math by watching someone else do it, and that's pretty rough, but here we go. I would say 81 to the fourth root is the first thing I think about. So 3 is the fourth root of 81, so I've taken care of the root, or the root, and now that 3 gets an exponent of 3. So 3 to the third power is 27. That's how I get my final answer of 27. Now I'm going to show you how you can get this done on the calculator. So we'll work with the square root of 9, and hopefully you know how to do the square root. There it is on this. You need to learn to make sure you can do this on Desmos, but I do second square root and I plug in the 9 and I get, of course, the 3. But how would you do that with exponents? You would take your 9 and the caret would raise. Now I need to raise it to the 1/3 power, but if you don't do this correctly, the calculator is going to give you something different. So I hit fraction 1, then fraction, then 3, and I screwed it up. What happened? Let's take a look. I need parentheses. So I take 9, I raise it to, now in the parentheses, I can do the fraction of 3. And I still screwed it up. You know why? Because I'm supposed to be doing a 1/2 fraction. Darn it. 9 raised to, we're supposed to be doing the 1/2 power. 1 divided by 2, now I get my 3. Or if I did 9, I'll clear this out, 9 raised to the 1 fraction 2, I get it. So the reason I was getting a wrong answer before is we were in the square root, or the second root, so I needed my fraction to be 1/2 instead of 1/3. Remember, you have to make sure that you're able to do this on Desmos. Don't assume that you'll be able to figure it out without practicing. So here I'm going to do 8 to the third root to the exponent of 4. We know that should be 8 to the 4/3 power. So let's get that 8 to the 4/3 into the calculator. This would be an 8 raised to, and I'm going to use parentheses to be careful, and I'm going to go 4 fraction 3. This better give me a 16, or math is broken. Math is not broken. One final thing to connect with the old rules that you know. Do you remember that when you multiply, you add exponents? So that works with fractional exponents too, like 4 to the 1/2 times 4 to the 3/2. If I add the exponents, I get 4 to the 4/2, which is really 4 to the second power, because 4/2 is really a 2, so that's 16. So now I can go ahead and multiply and use my previous properties even if there's fractions there. Check out this one. 8 times 8 to the 1/3. I would assume that you know there's a 1 there, and you can write that 1 there. So now if I'm multiplying, I add my exponents. 1 plus 1/3 is 4/3. 8 to the 4/3 power. 3 is the root, so the third root of 8 is 2. 2 to the 4th power is 16.